Introduction to milk and milk products. Composition and nutritional value of milk. As per FSSAI, milk is the whole, fresh, clean, lacteal secretion obtained by complete milking of one or more healthy milch animals, excluding that obtained within 15 days before calving or 5 days after calving. It should have the prescribed percentage of milk fat and SNF, solid not fat. The following table explains the composition of milk. Nutritional factor, energy value. Description: milk contains the protein casein, which is a high-quality protein. Milk contains all essential amino acids in appropriate proportion. Energy value 4.1 kilocal per gram. Nutritional factor, minerals. Description: milk contains calcium and phosphorus. Nutritional factor, vitamins. Milk. Description: milk is a good source of vitamins A and D, thiamine and riboflavin. Nutritional factor, fat. Description: milk fat plays a very important role in the flavor and physical properties of milk and its products. The fat content in milk is generally from 3.5 to 4.5%. Energy value 9.3 kilocal per gram. Nutritional factor, lactose. Description: lactose is the sugar component of milk. The principal function of lactose is to supply energy. Energy value 4.1 kilocal per gram. Different types of milk and its composition. The following table explains the different types of milk and their composition. Prevention of food adulteration, PFA, standards of different types of milk. Equipments used in a dairy processing plant. Raw milk reception dock. The place in the dairy plant where milk first arrives and is received after grading for acceptance is known as raw milk receiving dock. Milk is delivered to the dairy plant either in cans or in tankers. Since further processing of milk mainly depends upon its quality, the decision of accepting the milk must be done immediately after arrival and thorough investigation. Reception includes unloading, grading, conveying, sampling, testing, weighing or measuring, and recording, dumping and pumping. Storage tanks. Storage tanks are containers that hold hot or cold liquids used for short or long-term storage. In a dairy industry, the storage tanks are classified based on structure and heat preservation capacity. Storage tanks are available in many shapes, for example, vertical and horizontal, cylindrical, open top and closed top, flat bottom, cone bottom, slope bottom and dish bottom. Milk chiller. Chilling of milk is the rapid cooling of raw milk to sufficiently low temperature to check the growth of microorganisms present. In chilling process, the temperature of milk should be reduced to less than 10 degrees Celsius. Milk separator. A separator is a centrifugal device that separates milk into cream and skimmed milk. Homogenizer. Homogenization is the process used to make a uniform mixture of two mutually non-soluble liquids. This is achieved by turning one of the liquids into a state consisting of extremely small particles distributed uniformly throughout the other liquid. Pasteurizer. Pasteurization of milk is the process of heating milk to 63 degrees centigrade for 30 minutes or 72 degrees centigrade for 15 seconds in order to kill microorganisms that could cause spoilage, disease or undesired fermentation of food. After pasteurization, the milk is immediately cooled to 5 degrees centigrade or below. The purpose of pasteurization is to increase milk safety for the consumers and to enhance the quality and shelf life of milk products. Milk packaging machine. Most dairy processing plants use the form-fill seal to package processed milk and milk products. This machine is ideal equipment for packaging free-flowing type or granular food products. Let us summarize what we have learned once more. Manufacturing process of cheese. Milk is brought into the factory every day. All milk must pass a test before being unloaded into the factory. Raw milk starts out at 38 degrees Fahrenheit to 42 degrees Fahrenheit and is then heated to 165 degrees Fahrenheit for 18 seconds. This heat treatment results in the pasteurization of the milk. The pasteurized milk is pumped into the cheese vat at a temperature of 85 degrees Fahrenheit. This vat holds up to 1,750 gallons of milk. The milk temperature is raised to 88 degrees Fahrenheit in order to prepare the milk for the addition of the culture. Culture is added to milk and is allowed to ripen for 60 minutes. An enzyme is added to the milk, causing it to coagulate and become curd. Coagulation of milk into curd. Milk temperature is critical during this stage. Our target time for the coagulation of the milk into curd is 35 minutes. Cutting the curd. The coagulated milk is cut into 3/8-inch cubes by pulling curd knives. These cubes will become cheese curds. At this point, the whey starts separating from the curds. Whey is the liquid portion of the milk that does not become cheese. Resting and healing of the curd. The curd is very delicate immediately after it has been cut. The whey and the curd begin to separate. The curd is gently stirred by hand using a cheese squeegee to separate the curd from the surface of the vat and move the curd around in the mixture of curds and whey to allow the surface of the curd to heal before the start of the cooling process. Cooking the curd. During the cooking process, the mixture of curds and whey are gently cooked by raising the temperature from 88 degrees Fahrenheit or 90 degrees Fahrenheit, depending on the type of cheese, to 100 degrees Fahrenheit over a period of 30 minutes. Draining the whey. After the curds and whey have reached the desired temperature, pH, and time targets, the whey is drained off. At this point, the cheese-making process will vary depending on the type of cheese being made. Packing cheese curds. The small cheddar cheese curds are pushed along each side of the vat and allowed to knit together. The knitted curd is cut into cheddar cheese slabs, which are then turned. The slabs are turned to allow moisture to escape. The key thing that is happening during this phase is that the curd is developing more acidity. The cheddar cheese slabs are turned about every 20 minutes. Milling the curd. The cheddar cheese curd is run through a mill and chopped up into smaller pieces. This allows the salt to more easily penetrate the curd. Salting the cheese. The salt acts as a preservative, draws out excess moisture, enhances flavor, and participates in the natural aging of the cheese. Preparing and lining the hoops. The cheese molds, called hoops, are lined with disposable cheesecloth, which keeps the curd from sticking to the hoop and helps to form a smooth outer surface. Hand filling of the hoops. The milled cheddar cheese curds are moved from the vat by hand using flat-sided buckets. Topping off the hoops. Once the hoops are filled to the desired level, the cheesecloth is pulled up over the curd and a stainless steel lid is applied. The cheese is pressed. The lidded hoops are turned on their side and pressed at 40 lbs per square inch. Removing the pressed cheese from the hoops. The next morning, the pressed cheese is removed from the hoops and packaged. Each block of cheese is placed in a special nylon pouch and vacuum sealed for aging. Vacuum packing. The block of cheddar cheese is placed in a vacuum chamber machine. The vacuum chamber machine removes the air from the pouch and seals the package. The packaged cheese is put in a cardboard box and labeled. The boxed cheese is then placed in the cold room to age to the desired flavor. The aging temperature is between 40 to 42 degrees Fahrenheit. Aging can range from several weeks to 24 months. Let us summarize what we have learned once more. Packaging and storage of finished dairy product. Packaging of finished product. The packaging of dairy products is very important to preserve its nutritive values. The challenge to the packaging industry is to deliver the nutritious milk to the consumer in most economical, hygienic, safe, and environmentally friendly package. Hence, it is important to choose the right packaging material. Some of the commonly used packaging materials used in the dairy industry are paper, paperboard, and corrugated fiberboard. Stock rotation system like FIFO and FEFO are applied. FIFO, first in, first out, is a stock rotation system that dispatches processed food depending on the order in which it is produced. FEFO, first expired, first out, is a stock rotation system wherein products that need to be consumed earlier are shipped first. Roles and responsibilities of dairy product processor. Let us now take a look at the roles and responsibilities of dairy products processor. Handle raw material from recipient to the process line. Check the raw material for quality. Ensure minimum loss of raw material. Record keeping and documentation. Document and maintain records of raw materials. Document and maintain records of production schedule and process. Document and maintain records of finished products. Maintenance of hygiene and sanitation. Adopt safety and sanitation related measures. Follow food safety norms and practices. Operate dairy equipment and machineries. Optimize the use of machinery. Ensure smooth operation of machinery to complete production line. Inspect machines and troubleshoot issues. Attend to minor repairs of tools and machinery when required. Ensure that safety rules and regulations are observed. Prevent accidents. Plan and execute the production process. Examine products at different stages of production. Adhere to good manufacturing practices, GMP. Inspect intermediate as well as finished products. Achieve quality and quantity products. Ensure the products meet the quality standards set by the organization. Follow storage and packaging norms. Ensure safe and proper storage of raw material, packaging material, and finished goods.